Hi, hello everyone. This is Ameer, your physics educator at Unacademy, and every one of you, welcome to another beautiful session. And here we are with the third lecture of Kinetic Theory of Gases. आप सब लोगों को पता है. And the topics that we'll be discussing is Partition of Energy, ठीक है, specific heats, and finally we'll be ending this particular chapter with the concept of the mean free path. So a lot much is there on our plate to be completed today. I hope you all came with full of energy and with full of enthusiasm and with full of excitement. So yes, मेरा बच्चा लोग, let's get started, है ना? Let's get started with the session. So before we start with the session, tell me, कैसे है मेरा बच्चा लोग, कैसे है? How are you all doing? Hi Anchal, hi Sumit, hi Rukshar. बच्चा लोग आप सब लोग कैसे हैं? जल्दी जल्दी फटाफट बता दे. Every one of you here, tell me कैसे? सब बढ़िया? Are you all doing good? Hi मेरा, hi Sumit. मेरा दिन तो बढ़िया था. It was good actually. I hope you guys also had an amazing day, isn't it? Good evening Shreya. Anjal, fine. I'm feeling fever, Pardeep? Okay, so Miara is asking what made you happy today. So I'll just tell you one single story here. It's not a story. I don't know how do you take it. So this will be the last month for me in Unacademy. Okay? So I'll be having my classes. I'll be continuing my classes till the end of this particular month. Okay, and I'll try to complete all the portions for your term 2 examination. I'll try my level best. I think mostly it'll be completed within this month. Okay? With a bilkul बढ़िया, and this decision was taken today. I thought of telling you before we start with the classes. Okay, fine. ठीक है ना? Hi Jia, hi Abhimanyu, hi Sikendra, Sumit, Zafar, Rukshar. Good evening, Mithilesh. Why? So many reasons, है ना? So let's see what are the reasons, and obviously as we move along, okay, I'll be telling you. Anyway, let's proceed with the chapter, and let's proceed with the session, mera bachcha log. Right, and if you're seeing me for the very first time, a bit of introduction about myself. I hope you all can see it on the screen, है ना? I have an experience of more than 3.5 years, BTech graduate from NIT Calicut in mechanical engineering, ठीक है? Now, the schedule for this particular week I am showing you. As you all can see, this session is being cancelled, okay? It won't be there at 10 p.m. today. So this will be the last session for the day at 8 p.m. and tomorrow we have two sessions. One is thermodynamics for you all people 11th, and for 12th standard we'll be starting a new chapter of modern physics. Now all updates about this channel will be available in the Telegram channel. Okay? Link is given here and in the description box. Bugs Bounty, it's an amazing program to help you get prices. If you find any inappropriate content in the videos uploaded by Unacademy, you can report it, and if it is valid, outside prices mil jayega. Now Combat scholarship test is happening, mera bachcha log. If you want to grab lot many prizes, this is your chance, okay? First rank with gold medal, second rank silver medal, and third rank with bronze medal, along with 1 year of free plus subscription for the first 3 ranks. Don't miss it. And those who don't know, the code for joining the scholarship test or registering for the scholarship test is completely free, and you simply have to use the code of AMB10. It's M, right? It looks like M itself, I suppose. ठीक है? Then बच्चा लोग, you all can share the class to all your friends and tell them that the class has started, and I think this is going to be the last class of the Kinetic Theory of Gases. After this we'll be starting a new chapter. Now if you haven't heard about the Unacademy Plus subscription platform, you must join, because there are so many amazing features which is waiting for you. Okay? So you will have unlimited access to all courses. Top educators with a very good experience will be there to teach you. Study materials, practice tests, live test series. You are going to enjoy a lot once you are a part of an Unacademy Plus subscription. Now if you go for 12 months, it should cost you 1,250, but we have our code, right, which is AMB10. Use it, get 10% of discount and maximum offers while you make the subscription. Now we have Iconic subscription, and Iconic extra features are also there along with the plus subscription features. So here we have a personal mentor. Another person will be assigned to you. He'll be dealing with all your academic planning things. Okay? So then light doubt solving classes, weekly reports, everything is just going to make you super confident and will build your knowledge like anything. Now if you go for 12 months, it should cost you 2,333, and as you all know, 10% discount to here, and you simply have to use the code of AMBT. Fine. And already shared and liked. Wow, Jia, wow, amazing, awesome. So tell me, Vajaluk, are you all ready for the session? Ready. Anyway, I have to tell you, right? It's totally fine. Come learn. We have to learn. We have to prepare for the examination. And many things happen in our life. We have to keep on moving forward. Because the life is always about moving forward and trying to have some memories when you look backward, right? And soon our classes will be your memories, and you can think about me when you reach at some classes, that awesome moments we have shared together. Okay, so Mithilesh, Shreya, everyone, ready? Oh, Preeti, thank you so much for those amazing words there. Thank you so much. Tanisha, good evening. Ready? Okay, let's get started. Now, actually, we are here to talk about the law of equipartition of energy. Tell me, what does this word of equipartition brings into you? What meaning or what idea does it brings into your mind? Equipartition of energy matlab equally partitioning or equal distribution of energy. Yes, we are going to discuss about the concept of equal distribution of energy itself. Okay, how it is equally distributed and where it is distributed, let us understand. Okay, now for helping you understand or to help you get the complete and the actual concept, I have to ask you one simple thing. Tell me, Vachalu, if you are having a particle, let's say it is having a mass of m, and if it is moving with a velocity of u, we have a molecule of mass m and moves with a velocity of u. The kinetic energy associated was given by the value. Tell me, yesterday we have to write. The kinetic energy was given by the value of 3 by 2 kb into t. Yaad hai? Right? The total kinetic energy associated with it was given as 3 by 2 kbt. Now, I'm going to give a chotu name for this kinetic energy. This mass, because of its speed of u, isn't it moving from one point to another point? Let's say this mass is having a speed. The speed is given as u. So if it is seen here, after some time, it will be seen here because it is moving along that particular line. So this speed is helping the body to move from one point to another point. So the kinetic energy associated with this speed, we call it as translational kinetic energy. If a body moves from one point to another point, that motion we call it as translational motion. I hope everybody knows, right? And what I am telling you right now is the kinetic energy associated is given by the name of translational kinetic energy. So this 3 by 2 kbt is called as the translational kinetic energy of the particle. This is very important. Why translational? Because particle move from one point to another. Okay, fine. Okay, let us continue. Now, if u is the speed, how can you write the kinetic energy translational formula? Very simple. Half m u square is equal to 3 by 2 kbt. Yes or no? Yes. Now, if the particle, let's say it is moving in space, obviously if the speed is u, it will be having its x component, and I am marking it as ux. It will be having its y component. Its y component, let me mark it as uy, and its z component of speed, let me mark it as uz. Yes or no? Yes, okay. Now, with respect to its component, how can I write its kinetic energy? Its kinetic energy in the x direction, which is half m ux square, plus its kinetic energy in the y direction, half m uy square, plus and its kinetic energy in the z direction, half m uz square. Matlab, the same kinetic energy of the body I have expressed in terms of its speed components in x, y and z direction. That's it. So obviously, if the left hand side is same, right hand side तो same ही हो जाएगा KBT, है ना? और क्या? Now, how many of you do remember? Yesterday I have told you one simple concept. What was it? Array, the particle has the equal probability to move in all the direction. It moves in x direction, y direction and z direction. It has equal probability to move in all the direction. And as there is equal probability, we already know that ux ka value, uy ka value and uz ka value equally ho jayega. Yes or no? So half mu square I am going to substitute as ux square. Half muz square also I am going to substitute as mux square. So half mu square will be added 3 times. So this will be 3 times half mux square is equal to 3 by 2 kBt. है ना? Now this 3 on both the sides will get cancelled. So you can have half mux square is equal to half kBt. Matlab, we just found out that the kinetic energy of the body in the x direction is equal to half kBt. है ना? Isn't this what we got? Because half mux square is the kinetic energy in the x direction. Uska value हमको मिल गया half kBt. And we also know that ux का value equal to ui. So this is equal to half mui square. देख ले, ux का value equal to ui and uy का value equal to uz. So this is equal to half muz square. मतलब the kinetic energy not only in the x direction, the kinetic energy in the y direction, kinetic energy in the z direction is equal to half kBts. इसका मतलब क्या है? The total kinetic energy of 3 by 2 kBt is equally divided along x direction, y direction and the z direction, where each is having how much? Half kBt value. इधर तक समझ में आ गया? Okay, total kinetic energy is getting equally distributed along x direction, y direction and z direction. Clear? And this concept is simply called as equipartition of energy. क्या है? Equipartition of energy. क्या है? What is equipartition of energy? Now everybody can give a definition. बस चलो आप ही बोल गए, समझ में आ गया ये equipartition of energy क्या होता है? अरे total kinetic energy of the body is getting equally distributed in all the directions of motion. Is it clear? Clear? है ना? बता दे विकास, प्रकाश, श्रेया, निखिल, अविष्का, आ गया तो आ गया. Equipartition of energy क्या होता है? ठीक है. Can we write the definition also? Yes, we can do that, right? देख ले. Equipartition of energy is, right, dividing the energy equally between all the possible directions is what we call it as equipartition of energy. ठीक है, हम तो एनर्जी तो इक्वली डिवाइड कर रहे हैं. ठीक है, फाइन. आई होप यू ऑल हैव नोटेड इट डाउन. नाउ वन मोर थिंग आई हैव टू ऐड इट. देख ले, when it is moving along x direction, right, it is bringing 1/2 kBt of energy. ठीक है. Now when it is moving in the y direction, it is adding another 1/2 kBt. Now when it is moving along z direction, it is bringing another 1/2 kBt. Right. So for every direction of motion, it is bringing one energy level of 1/2 kBts. Now the total number of motions which brings an energy level of 1/2 kBt, we call it as what? उसका नाम क्या है? Energy mode. What is energy mode? Did I tell you? The number of motions, once again, the number of motions, right? The number of motion which brings an extra energy of 1/2 kBt or which brings an energy level of 1/2 kBt is what we call it as. What do we call it? जल्दी बताओ, what do we call it? नाम क्या है? Let me see who's going to tell me that. It is called as energy mode. So tell me, how many energy modes are there? Particle moves in x direction, it brings half kBt, so 1. It moves in y direction, it brings an extra half kBt, 2. It moves in z direction, it brings an extra half kBt, so 3 energy modes are there. समझ में आ गया? समझ में आ गया? That is total number of motions, right? A particle can have to bring an energy level of half kBt, that is energy mode. ठीक है? Let us write. Energy mode क्या होता है? What is energy mode? Everybody can write. That is total number of motion. कितना motion है? Okay, which brings an energy level of half kBt. Okay, we call it as energy mode. समझ में आ गया ना? If it is moving in x direction, it is bringing half kBt. If it is moving in y direction, it is bringing half kBt. So if it is moving in z direction, ठीक है, it brings another half kBt. तो कितना energy mode से in the above explanation, in our above example, कितना energy mode से? 3. ठीक है? This is 3, and this energy mode is itself as called as degree of freedom. This is very important. Degree of freedom. Sing. Degree of freedom क्या आता है? Total number of energy mode. कितना energy mode है? That is equal to degree of freedom. What is the number of energy modes in the above case? 3. So degree of freedom कितना है? 3. समझ में आ गया? Okay. So don't have to get confused. अरे sir ये degree of freedom क्या होता है? It is very simple. Okay. It is the total number of energy mode. So you can ask yourself, what is this energy mode? It is a total number of motion which can bring an extra energy level of half kBt. वही होता है energy mode. So degree of freedom is usually expressed with the symbol of F, and degree of freedom we usually write it as D or F in short. Clear? Is it clear? Yes, degree of freedom, Mithilesh, very good. बहुत बढ़िया. ठीक है, डिग्री ऑफ फ्रीडम इज इक्वल टू कितना एनर्जी मोड्स होता है, वो होता है डिग्री ऑफ फ्रीडम. आ गया ना समझ? आ गया ना समझ? ओके. नाउ देख ले, फॉर एवरी डिग्री ऑफ फ्रीडम और फॉर एवरी राइट एनर्जी मोड्स देयर विल बी एन एनर्जी ऑफ हाफ kBt. समझ में आ गया? मतलब इफ इट इज मूविंग इन एक्स डायरेक्शन, we say that energy mode is 1, and that one energy mode will be bringing half kBt. Right? I'll write one energy mode or one degree of freedom will bring an energy of half kBt. Let's say there are 2 degree of freedom. मतलब 2 energy modes are there. Okay, मतलब moving in x direction and y direction. Moving in x direction will bring half kBt. Moving in y direction will bring another half kBt. So for 2 degree of freedom, there will be 2 times half kBt. ठीक है? So in general, for any molecule or a particle, if there is f degree of freedom, its total kinetic energy will be equal to f times half kBt. आ गया समझ? Its total kinetic energy is equal to f times half kBt. ये तो this is the core of this chapter. Okay, ये होता है the core of this particular chapter. इससे ज्यादा important, ठीक है, और कुछ नहीं. क्लियर? सुमत, जिया, श्रेया, नांसी, जल्दी राइट डाउन कर ले. दिस इज इंपॉर्टेंट पार्ट. ये तो इंपॉर्टेंट है. Now we are going to discuss the degree of freedom for monoatomic, diatomic, triatomic. बहुत सारे questions करने वाला है, बहुत सारे. There is so much of things on your plate or in our plate to get done. Got it? Noting? Noted? Sumit? वाह मेरे बच्चा लोग, वाह. Clear and understood? Shraddha? अरे वाह. Along with me? अरे वाह. You guys are so super fast nowadays. ठीक है. Now shall we find out the kinetic energy for monoatomic, diatomic, triatomic? Okay, in each and every different cases, right? What is the kinetic energy? Degree of freedom कितना है? Everyone? ठीक है, देख ले. First we will take monoatomic molecules. अरे monoatomic molecules का मतलब क्या है? अरे a molecule which has only one single atom. Examples helium, neons, all these are examples of monoatomic molecules. सबको पता है, right? Okay. Now we are asked to find out its total kinetic energy. ठीक है. Now for finding out the kinetic energy, we all know that we first have to find the degree of freedom. Take the monoatomic particle here, a cat. Okay, it can move in x direction, right, which brings a degree of freedom of 1. It can move in y direction, which will bring one more degree of freedom, because for each motion, right, there will be an energy mode of half kBt. We already have learned that. ठीक है. Now it can move in z direction also, which will bring an extra degree of freedom. मतलब for a monoatomic molecule here, right, it can make a translational motion in x direction, translational motion in y direction, and translational motion in z direction only. Right? Can it have any other kind of motion? No. It can move from one point to another point. That's all it can have. So tell me how much degree of freedom this monoatomic molecule can have. कितना हो सकता है? 1 plus 1 plus 1, that is 3. And let me make it more and more clear. This degree of freedom is because of the translational motion, है ना? मतलब the particle is moving from one point to another point in x direction, in y direction and in z direction. मतलब all these degree of freedom, which is 3 degree of freedom, is because of translational motion. So this degree of freedom, specially and specifically, we call it as translational degree of freedom. And for a monoatomic particle, the translational degree of freedom hota hai 3. And you will learn that all the particles will be having a translational degree of freedom of 3. Okay, we'll come to it later. For the time being, ye mark kar le. Just note this down. ठीक है, हो गया इधर तक. Translational degree of freedom होता है 3 for monoatomic molecule. ठीक है. So इसका degree of freedom 3 है. So kinetic energy कितना होता है? What is the total kinetic energy? अरे total kinetic energy is equal to F times half kBt. ठीक है. F कितना है? F तो 3 है. 3 into half into kB into T. मिल गया. So the total kinetic energy for a monoatomic molecule भी मिल गया 3 times half kBt. Only this much, nothing more than that. Got it, got it, got it. Nancy, Jia, Shraddha, Nikhil, Amrita, Shraddha. बोल दे हाँ या नहीं. मिल गया तो बता हाँ सर बिल्कुल अच्छे से समझ में आ गया. Right? Okay, note भी कर ले because we'll be jumping to diatomic all of a sudden. Perfect, got it. अरे वाह प्रीति, next amazing line from you, thank you. ठीक है. So I hope you guys have noted and हम चल रहा है diatomic पे. Diatomic molecule. Examples are H2, ठीक है, O2 and all. Okay, in a molecule there are 2 atoms. So if we try to represent that molecule, ऐसा होता है. One atom इधर होता है, another atom इधर होता है. ठीक है. Can it move along x direction? Can it move along x direction? Yes. Can it move along y direction? Yes. Can it move along z direction? Yes. So this diatomic molecule can also move along x, y and z direction. So obviously it can bring a translational degree of freedom of kitna? 3, like we already have discussed. ठीक है ना? Okay. At the same time, now we can realize that this is not the only kind of motion the particle or a diatomic molecule can have. पूछ ले और क्या हो सकता है सर? I am going to draw a line here. मतलब a y-axis through the center of this diatomic molecule. Tell me, can this diatomic molecule rotate about this y-axis? Yes, it can rotate. If it is rotating, is it bringing any other energy to here? Yes, it is bringing another kinetic energy. If we have another motion, and if that motion is bringing another kinetic energy, Can we say that this motion adds an extra degree of freedom here? Yes. So for a diatomic molecule, we can expect a rotational kinetic energy. आ गया समझ? A rotational kinetic energy will be there, which will be adding an extra degree of freedom of 1. ठीक है? Because for every energy mode, there will be an extra degree of freedom. ठीक है? Is that the only case? नहीं. देख ले, just like y-axis, we have the z-axis. Can't it rotate about the z-axis also? Z-axis, which is projecting out of the plane, can't it rotate? Yes. If it rotates, will it add an extra rotational kinetic energy? Yes. If an extra energy is added, will it increase the energy mode and degree of freedom by 1? Yes. So, as it is rotating along z-axis, degree of freedom will increase by 1 more. So, it is rotating along x and it is rotating along y and z. Question. You all will be having. Sir, can't it rotate along x-axis also? Let's see. Isn't this the x-axis? Yes. Now, if I am drawing the x-axis is along the principal axis of that diatomic molecule. So, the kinetic energy is 0 hota hai. Kyun? Because kinetic energy formula for rotation is half I omega square. And the value of I is equal to mr square, where r is, ये r है ना, r is the distance of the particle from the axis. ये तो particle है, ये तो axis है, distance भी नहीं है, because the particle lies on the axis. So r will be approximately 0 होता है, बहुत छोटू होता है, will be approximating to 0. I 0 होता है तो kinetic energy in the x direction 0 होता है. So its rotation along the x-axis is not bringing an extra energy, so it will not add up to another degree of freedom. आ गया समझ? So for a diatomic particle, because of a rotation, it adds up 2 degree of freedom. Plus 1, 2. So along with 3 translational degree of freedom, a diatomic particle has 2 rotational degree of freedom, which makes the total degree of freedom kitna? What is F? The total degree of freedom, how much is it? Initial 3 plus 2, total ho gaya 5. Okay, aa gaya samajh? Yes? Yes? Okay, Sapna, Shreya, Rukshar. हाँ, अरे डिग्री ऑफ फ्रीडम 5 हो गया तो काइनेटिक एनर्जी का फॉर्मूला कितना होता है? अरे काइनेटिक एनर्जी का जनरल फॉर्मूला इज F times half kb into T, isn't it? Yes. Here F becomes 5, so 5 times half kbt. This is the kinetic energy and degree of freedom for a diatomic molecule which is rigid. मतलब it is fixed at a particular position. उधर fixed है molecule. Okay, for a rigid molecules of diatomic, usually the kinetic energy is 5 times half kbt. Okay. Fine. Okay. Now in diatomic molecule itself, we are going to find a chotu slight change also. देख ले. Okay. Now we were discussing about diatomic molecule which is so much rigid, right? Or let's say at very low temperature. Now let's say we have a diatomic molecule. We have a diatomic molecule which is not so rigid. Not rigid. I'll explain you not rigid का मतलब क्या है. As it is a diatomic molecule, we already have discussed translational degree of freedom. Already will be there 3. ठीक है, rotational degree of freedom 2, that will also be there. Now along with this, हो क्या हो सकता है? अरे this diatomic molecule, if it is not rigid है ना, it can vibrate. This particle can vibrate ऐसे देख ले. It can vibrate ऐसे. It can vibrate. Can you see that? Okay. So this vibration means movement of the particle. So it adds 1 kinetic energy. Okay. At the same time, its position is changing. पोजिशन चेंज हो जाता है तो when the position is changing, one more energy will be produced. Which one? Potential energy. Which means because of vibration, an extra degree of freedom of 1 plus 1, 2 is being added up, and this is the only case for diatomic molecule which is not so rigid. वो तो rigid नहीं होता है तो extra 2 degree of freedom will be there because of vibration. ठीक है, मूवमेंट मतलब काइनेटिक एनर्जी भी है, पोटेंशियल एनर्जी भी है. फॉर काइनेटिक एनर्जी 1 डिग्री ऑफ फ्रीडम, फॉर पोटेंशियल एनर्जी अनदर डिग्री ऑफ फ्रीडम. 1 + 1 कितना होता है? कितना होता है? 2. ओके, सो टेल मी फॉर डायटोमिक मॉलिक्यूल व्हिच इज नॉट सो रिजिड, और समटाइम्स इन द क्वेश्चन दे विल स्पेसिफाई हाई टेम्परेचर. In that case also we'll have to say degree of freedom will be equal to 3 translational plus 2 rotation plus 2 vibration. So 3 plus 2 plus 2 होता है 7. ठीक है, diatomic molecule not so rigid. Kinetic energy कितना? 7 times half kBt, because F is 7 here, 7 times half kBt. हो गई बात? हो गई बात? All good, all good. जल्दी राइट कर ले. We'll have to move for triatomic also. Very good. ठीक है ना? Okay. Now we have triatomic. We'll be discussing triatomic like 2 different cases, like we have discussed about diatomic also. One is triatomic, that is non-linear, fine, and rigid. As it is rigid, there won't be any vibrational degree of freedom here. Okay, and because of non-linear, how many degree of freedom will be there? We'll discuss. Give me an example of a triatomic molecule which is not linear. If I'm correct, sulfur dioxide, है ना? Sulfur dioxide is a non-linear triatomic molecule. How can you draw this sulfur dioxide? S तो इधर होता है, oxygen इधर है, oxygen इधर है. You guys are best, मुझे पता है, right? Okay, this is how a triatomic non-linear molecule looks like. First tell me, for this, how many translational degree of freedom होता है? अरे for every molecule translational will be 3 because it can move in x, y and z. वो तो fixed है. Fine. Along with translational, it will be having rotation. In how many axes? देख ले. Everybody listen. This is very important. It can rotate about y axis, right? Because about the y axis, oxygens are being spread out. It will be adding an extra kinetic energy. So obviously 1 degree of freedom. It can rotate about z axis. देख ले. Can you see? It can rotate about z axis because with respect to z axis also oxygen molecules are spreaded out, right? ठीक है. So obviously it will be adding extra kinetic energy of rotation, which means an extra degree of freedom. Here, it can also rotate about x axis. Can't it also rotate about x axis? देख ले. The oxygen है ना, देख ले, the line is moving along x axis. If you consider the tips of my fingers as 2 oxygen, this oxygen can rotate ऐसे, देख ले, ऐसे. Can't it go zoom? Yes. Which means here in this case, the rotation of the particle along the x is not 0, it is having a specific value. So if it is bringing 1 extra kinetic energy here or 1 energy mode here, the degree of freedom will be increased by 1. So tell me here, what is the rotational degree of freedom? Is it 1, is it 2, or is it 3? वो 3 है. Because it can rotate about x axis, y axis and z axis. Okay, as it is rigid, there is no vibrational. So total degree of freedom होता है 3 + 3 6. है ना? अरे वेरी गुड. वराद, माही, जिया, सुमित, रुखसार, वही है, 3 होता है ना? और क्या. Amazing. Now देख ले. So F is 6, Tell me what will be the kinetic energy. Our kinetic energy is F times half kBT. F is equal to 6 here. So 6 times half into kB into T sir. आगे समझ बोल दो ना जरा आ गया. Triatomic non-linear is done. Clear? Okay, one more part, then we are done with this equipartition, kinetic energy distribution and degree of freedom part. Clear? Right, Sumit, Jia, Mithilesh, Prakash, Nancy. Wow, awesome. Anera, Mahi, theek hai, dekh le. One last part. Okay. Now here we are having triatomic. We have discussed non-linear. We'll discuss about linear and not so rigid. Not so rigid matlab it can have vibrational degree of freedom or vibrational kinetic energy. Okay, fine. For a triatomic, which is linear, example carbon dioxide, है ना? ठीक है. CO2. So at the center we have carbon, double bond O, double bond O. Double bond ही है ना? Tell me, double bond ही है ना? You guys are the masters of chemistry. Tell me, double bond है या single bond है और triple bond है? Yes, carbon dioxide double bond. Yes, okay. So everybody confirms. So I'm not. So I'm damn sure right now because all my bacha logs have confirmed. You know, ठीक है. So we have a carbon dioxide as a linear here and not rigid. Obviously, without any doubt, we can say that as it moves in x, y, and z, translational degree of freedom 3 होता है. Okay. Now there is one single problem मेरा चलो देख ले. The only difference between the non-linear and linear triatomic molecule is, can it rotate about y-axis? Yes, which will add 1 degree of rotational, okay, 1 degree of freedom of rotation. Can it rotate about z-axis? देख ले, ये तो z है. Can it rotate? हाँ, it can rotate ऐसे. ठीक है, as zoom, it can rotate. So it will add 1 more degree of freedom of rotation. But here, as it is linear, can it rotate about x-axis? Can it rotate about x-axis? Right? It can just spin. But as we already have discussed, the kinetic energy that will be added is very small, or which can be neglected, or it will be almost approximated to 0. क्योंकि kinetic energy is half I omega square. ठीक है, I का value होता है mr square, where r is the distance from the axis to the body. अरे axis and the body are coinciding, so r का value 0 होता है, so I का value 0 होता है. मतलब kinetic energy will not be added when it is rotating in the x direction, so it will not bring any extra half kBT energy or energy mode, so degree of freedom will not be added. ठीक है, so it can rotate about x, sorry, it can rotate about y, it can rotate about z, so 2 degree of freedom. ठीक है, दो. Now देख ले, we haven't complete rigid नहीं है, it's not rigid, so can't we have vibrational degree of freedom also? How much? 2, because when vibrate, 1 kinetic energy mode and 1 potential energy mode will be added. So for triatomic linear, which is not rigid, total degree of freedom होता है 3 plus 2 plus 2 7. ठीक है, so kinetic energy होता है F times half kBT, and what is F here? 7 times half kBT. हो गई बात, आ गई समझ. Clear? Every one of you बता दे. Yes. And if you guys are ready for start doing the problems, tell me, sir, we are super ready. Let's get started. Clear? Preeti, Sumit, Jia, super clear. अरे वाह. वराद, मुस्कान, प्रकाश, सब रेडी है. ठीक है, क्लियर भी है, नोट भी किया ना, all different cases, right? Okay, so we are proceeding kinetic energy. First question. So this is a super नन्नू मुन्नू question, मतलब डायरेक्ट क्वेश्चन है, जल्दी बोलते, 10 seconds you all have to give the answer. For 1 degree of freedom कितना kinetic energy will be added? For 1 degree of freedom, for 1 degree of freedom, per degree of freedom मतलब for 1 degree of freedom. अरे for 1 degree, अरे this is 3/2 kBT is for 3 degree of freedom. अरे काइनेटिक एनर्जी का फॉर्मूला क्या है? F times half kBT है ना. क्वेश्चन इज पर डिग्री ऑफ फ्रीडम मतलब for every 1 degree of freedom, मतलब if degree of freedom is equal to 1, काइनेटिक एनर्जी कितना? 1 into half kBT. अरे यार डोंट कैंसल बोथ द के, दिस इज KB बोल्ट्जमैन कांस्टेंट KB, वो KB अलग है, ये के द फर्स्ट के इज काइनेटिक एनर्जी, दिस इज बोल्ट्जमैन कांस्टेंट, सो ठीक है, नो वरीज, आई एडेड KB. नाउ यू वोंट कैंसल. हाँ फुजादी रुक्षार देविका, ठीक है, ऑप्शन सी है, पर 1 degree of freedom. Okay, 3/2 kBT was the total translational kinetic energy. क्यों? अरे because translational degree of freedom is 3. ठीक है, so translational kinetic energy is equal to translational degree of freedom, this is 3 into half kBT. So mix मत कर ले, understand the concept and learn. कोई बात नहीं, अगला क्वेश्चन करेगा, अगला क्वेश्चन कर ले, देख ले. Translatory kinetic energy of a gas per 1 gram. If I take 1 gram of a gas, ठीक है, उसका ट्रांसलेटरी काइनेटिक एनर्जी कितना होता है? कर ले. लेट मी सी हु इज गोइंग टू गिव मी द फर्स्ट करेक्ट आंसर. आज का बुद्धिमान और बुद्धिमती कौन है? Miara is like B, Arno, Mithilesh is like A, Sumit बोल रहा है A, Lucifer is B, Preeti is like A. Anyone gave me the option B? Anyone? Jia gave me the option B, Shreya gave me the option B, Lucifer gave me the option B, Miara gave me the option B, Mahi, very good, very good. Jia, Shreya, Raksh, okay, Mahi, very good. वो तो option B. I'll explain in detail. Okay, we'll take a fresh page and let me start explaining. Now, tell me what is the translatory degree of freedom? That's 3. So tell me what is translatory kinetic energy for any particle? So that is equal to F times half kBT. So translatory degree of freedom कितना है? 3 into half into kB into T. This is for one single molecule, एक molecule को. Now, for Avogadro number of molecule, what will be the kinetic energy? Kinetic energy total for Na molecule, for Avogadro number of molecules को कितना होता है? अरे one molecule it is 3 into half kBT for 1. So if it is 2 times 3 into half kBT. So let's say that Na number of molecule is there. How much will be? 3 into half kBT into Na. है ना? ठीक है. Who is going to tell me? Kb into Na क्या होता है? Boltzmann constant into Avogadro number. Anyone? अरे that is equal to R, universal gas constant into T. जिसको पता नहीं है नोट कर ले अभी. Kb into Avogadro number is R, which is universal gas constant. Very important है, ठीक है, very important है. So if I take Avogadro number of molecules, मतलब 6.022 into 10 power 23 molecules if I take, what will be the mass of all these molecules? Mass कितना होता है? अरे it will be having molar mass. It will be having molar mass of M. So Avogadro number of molecule, if the kinetic energy is this, we can say that for a molar mass of particle, the kinetic energy is equal to 3/2 RT. इधर तक समझ में आ गया? Okay, for molar mass of M it is 3 by 2 RT. So tell me, what will be the kinetic energy total for 1 gram? And for molar mass it is 3 by 2 RT. So for 1 gram how much it will be? Divide kar le 3 by 2 RT divided by M. Isn't it? बोल दे हाँ या नहीं, बोल दे हाँ या नहीं. So मिल गया हमको उत्तर. Kinetic energy total for 1 gram of any molecule is given by 3 by 2 RT by M. So here I have explained the concept in detail so that everybody can understand in the best way possible. Yes? Any doubts if you have, let me know. कोई भी डाउट है तो अच्छा लोग, दिस इज द टाइम. क्लियर? नोट भी किया ना? ओके ठीक है. नाउ लेट्स मूव टू नेक्स्ट क्वेश्चन. अगला क्वेश्चन. So if you have understood the previous question, I want every one of you to do this problem. ये तो बहुत अच्छा है. क्या है ये? बहुत अच्छा. No doubts when Ameer sir is here. अरे वाह, what an amazing line. Yes Prakash, 3 by 2 RT by 2M. Very good. Song time. Okay, let's see if it is song time or not. अभी problem कर ले. Answer. I just want the answer. हो गया? Everyone is giving option D. Who is given the option B? Mithilesh दे रहा है. Dumdur, Jia, okay, Sumit, very good. Option D correct है. Very good. Okay, I'll tell you. A gas has volume V and pressure P. The total translational kinetic energy of all the molecules of the gases, पूरा का पूरा molecules if you take, what is the total translational kinetic energy? We'll start from the scratches, from the beginning. Whether it is monoatomic, diatomic or triatomic, its translational degree of freedom कितना होता है? अरे translational degree of freedom will always be 3 because any particle, mono, di or tri, it can move along x, ऐसे jum jum jum. It can move along y, it can move along z. So translational degree of freedom for any particle, mono, di or tri or any poly, it will be always 3. So the translational kinetic energy will always be 3 times half kBT. This is for one molecule. Question is to find out for all the molecules. एक molecule तो इतना है. So tell me for Na molecule, for Avogadro number of molecule, just now we have discussed, that will be equal to 3 by 2 into kBT, which is for one molecule. And if you want to find out for Avogadro number, which is 6.022 into 10 power 23, क्या करना है? अरे multiply it with Avogadro number. एक molecule तो 3 by 2 kBT है. For Avogadro number 3 by 2 kBT into Na. बस. Okay. So this is equal to kB into Na क्या है? R. So for Avogadro number मतलब for 1 mole. अरे Avogadro number of molecules are actually called as 1 mole. So 1 mole molecules if I take, उसका kinetic energy 3 by 2 RT. ठीक है? 1 mole. Okay, tell me if there are n moles, n mole होता है तो what will be its kinetic energy? अरे 1 mole के लिए it is 3 by 2 RT. For n moles multiply it with n. So 3 by 2 nRT हो गया. 3 by 2 nRT. Have you seen this nRT before? पहचाना है क्या ये nRT को? अरे PV is equal to nRT. Ideal gas equation, PV is equal to nRT. So 3/2 PV. देख ले, mono, di or tri, whatever it is, the translational kinetic energy is 3/2 PV all the time. पूरा का पूरा time. Whatever happens, even if there happens an earthquake, कुछ ना कुछ हो जाओ, translational kinetic energy is not going to change. It is 3/2 PV for all kind of molecules. ठीक है ना? बोल दे हाँ सर, और क्या? अच्छे से समझ में आ गया, बढ़िया से समझ में आ गया. PV for sure. Okay. Tell me, how many of you are ready to learn some concepts? कौन ready है बच्चा लोग to learn some concepts? कौन ready है? Everyone. अरे right now we are going to learn है ना, molar heat capacity. I hope you do remember, right? How to find molar heat capacities for gases in different situations. Okay, according to mono, di and tri. Is there any specific formula for that? And we are going to derive those specific formulas here. ठीक है? Ready? Yo, let's go. Okay. Sir's expertise in concepts. Okay, ठीक है. देख ले. Everybody listen. पूरा का पूरा log देख ले. We are going to define for or derive for molar heat capacities. CP and CV याद है ना? ठीक है. So we'll start from the basics. Tell me, you do all remember about internal energy? याद है ना internal energy को? ठीक है. What was internal energy of a molecule or for a matter of a gas it is? Internal energy is the sum total of the kinetic energy plus potential energy. है ना? Now I'm going to tell you, I don't know how many of you are going to get shocked here. The potential energy value will be 0 for gases. ऐसे कैसे sir? Because there was one single postulates of kinetic theory of gases which said that between the gas molecules the force of attraction is 0. मतलब intermolecular और interatomic force of attraction 0 है. अरे force 0 है तो potential energy 0 ही हो जाएगा. क्यों? अरे because I hope you do know the formula that okay F is equal to minus du divided by dx. Force is equal to negative differential of potential energy with respect to displacement. याद है? याद है वर्क एनर्जी थ्योरम से? ठीक है, देख ले. इफ F 0 है तो पोटेंशियल एनर्जी 0 हो जाएगा, U 0 हो जाएगा. Isn't it? Yes or no? Isn't it? हाँ, कोई भी फोर्स नहीं है, फोर्स कुछ भी नहीं है तो पोटेंशियल एनर्जी 0 हो जाएगा. Okay, so we can write in the case of gases, internal energy will only be equal to kinetic energy. Internal energy will only be equal to kinetic energy. And kinetic energy का formula क्या है? F times half kBT. Isn't it? This is for one single molecule. For Avogadro number, एक molecule के लिए F into half kBT. For Avogadro number multiplied with Na. Which means for Avogadro number of molecule, kinetic energy is this. अरे Avogadro number मतलब 1 mole. Isn't it? Which means for 1 mole the kinetic energy is F into half kBT into Na. This is for 1 mole. Let's say there are n number of moles. Multiplied with n. ठीक है? Because F into half kBT into Na is for 1 mole उसका kinetic energy. Let's say there are n moles are there, multiplied with n. हो गई बात. ठीक है? So what do you have? Na into kB is R, right? So this will be F into half into Na into kB is R T N. So I'm going to write it as nRT. हो गई बात. इंटरनल एनर्जी का फॉर्मूला मिल गया मेरे बच्चा लोग. F in not F into half into nRT. मिल गया तो मिल गया, कॉन्सेप्ट तो मिल गया अभी तक. ठीक है. So this is internal energy. Change in internal energy क्या होता है? That is equal to F into half into N into R into. अरे internal energy will change when the temperature change. So change in internal energy is equal to change in temperature. है ना? So internal energy will only be changing when the temperature changes. So change in internal energy is equal to F into half into NR into change in temperature. बस इसमें ज़्यादा सोचने को क्या है, ठीक है ना. Now tell me, delta U we already have a formula. How many of you do remember delta U का formula? Tell me. Delta U has another formula NCV delta T. We have derived long before. याद है ना, long before हम तो derive किया है NR delta T. Cancel कर ले, what do you want to cancel? Delta T cancel, N cancel. So CV का formula we got that is equal to F into R by 2. देख ले, R by 2 with F. Very important. Very important. So for any kind of gases, if you want to find CV, which is I hope you all know ना, molar heat capacity at constant volume. Don't ask me, ठीक है CV क्या है सर, CV क्या है, पहली बार देख रहा है. अरे we have done this. Molar heat capacity, don't ask me, so CV क्या होता है, how to derive this, उसका concept क्या है, what is its formula. मत पूछ ले, मारूंगा मैं. Because we have discussed this so many times, isn't it? बहुत बार हम किया है. ठीक है, तो जल्दी से जल्दी बचा लो, मार कर ले एंड कॉपी कर ले. Dun 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 dun. Noted? Okay. Now we have derived an equation for CV. Array, when equation is being derived for CV, when CP listen to this or when CP sees this, he'll be so sad, है ना. CP will be thinking, अरे CV को you guys have derived a formula, मेरे लिए formula कुछ नहीं है. So we don't want to make a CP so sad, right? Let's make a formula for CP also. कैसे? अरे we know that CP minus CV equal to R. This also we have derived, right? So CP is equal to CV plus R. ठीक है, CV का फॉर्मूला क्या था, F times R by 2 plus R. To have a common denominator of R by 2, I am dividing this by 2 and multiplying this by 2. ठीक है, so that I can take R by 2 as common. Inside the bracket we have F plus 2. So CP का वैल्यू भी मिल गया, F plus 2 into R by 2, F plus 2 into R by 2. बहुत important. हाँ हो गया बात. So CV का फॉर्मूला मिल गया F into R by 2. CP का फॉर्मूला मिल गया F plus 2 into R by 2. If we have CP and if we have CV, we can simply find out one more thing. एक और, we can't we find out CP by CV? You will be thinking, sir, CP by CV, why we have to find out? अरे CP by CV was actually called as adiabatic constant, याद है? Do you remember adiabatic constant को? So that also we can simply derive. CP is equal to R by 2 inside the bracket F plus 2. CV is equal to R by 2 into F. हो गई बात, R by 2 cancel हो जाएगा. F plus 2 divided by F. F by F is 1 plus 2 by F. हो गई बात, गामा का फॉर्मूला. हो गई बात. Got it? मिल गया. बच्चा लोग जल्दी बोल दे, फटाफट बोल दे. बोल दो ना जरा. Gamma formula we just got it as 1 plus 2 by F. Myara, you cracked a lame joke there. Wow. Very clear, Prakash, Myara. Few questions चाहिए, ठीक है. ठीक है, तो दे दूंगा हम questions. Question चाहिए तो बिल्कुल दे दूंगा. Questions are on your way, मेरे बच्चा लोग. Questions are just like a bullet is coming, है ना? Questions are coming. You just tell me, are you ready to stop the bullet? मतलब, are you ready to do the problems? In simple way. Ready? जल्दी नोट कर ले all the formulas. CV का formula from this page. If you want, you can take a screenshot also. Right? CP का formula and gamma का formula. Good, awesome, fine. Let's go. Okay, here we go. Question to aa gaya. Shoot the questions, yes, shot the questions right at you, and here it is, and give me the answer. Ha, bilkul Preeti, I'll sing a song, don't worry. I promised you, so before we end the class, bilkul to ho jayega, गाना तो हो जाएगा. Okay, Mithilesh is going for option A, Prakash is for B, Jia is for B. Okay, Preeti A, Sumit B, Devika A. Arey, option correct though. A, 5/2 RT. Arey, bhul gaya. Everybody. Question is the total internal energy of 1 mole of rigid diatomic gas is. Internal energy U formula was, what was internal energy formula? That was equal to kinetic energy, because potential energy is 0 hai. So whatever is internal energy, that is equal to kinetic energy, right? What is the formula for kinetic energy? F times half kBT, right? This is for one single molecule. Question is for 1 mole, matlab for Avogadro number kitna hai? So you just have to multiply it with Na. Because one molecule is F times half kBT. For Avogadro number, multiplied with Avogadro number. So कितना हो जाएगा? F into half into kB into Na is R into T. Question is for diatomic gas. Diatomic degree of freedom is usually 5, half RT. You will be like, sir, there is a special condition of diatomic gas having a degree of freedom of 7, and that is a very special case at very high temperature, or when it is not so rigid. मतलब vibration होने के वक्त भी only in that situation when the diatomic molecule can undergo vibration, it is 7. If that is the case, that will be specified clearly in the question. If it is not specified for a diatomic gas, the degree of freedom 5 hai. If it is specified diatomic gas at high temperature, at high temperature and when it is not so rigid, in that case only degree of freedom is 5 plus 2, 7. Fine. Got it? Okay ना? आ गया समझ? आ गया? Okay. There you go. Next. In a gas, okay. So usually when it is being said as triatomic molecules, it is a non-linear triatomic molecules. Okay, समझ में आ गया? Whenever it is said only triatomic molecule, no other specification is given. We have to consider non-linear triatomic molecules. ठीक है. उसका Cp by Cv का value कितना होता है? Anyone answers? अरे Mithilesh already gave the answer. Very good, Mithilesh. Very good. It's option C. Very good, Jia, Preeti. Very good, buddy. बढ़िया मेरा बच्चा लोग. Option C है. अरे Cp by Cv is asked and it is gamma. Gamma का formula क्या है? 1 plus 2 by F. Just now. थोड़ी देर पहले we have to write. For triatomic molecules, usually degree of freedom, how much is it? 6. When is degree of freedom 7 for our triatomic molecule? When it is specified clearly that it is a linear triatomic molecules which is not so rigid. In that case, degree of freedom 7 hota hai. In the usual case, triatomic molecule comes with a degree of freedom of 6. So just substitute kar le. 1 plus 2 by F is 6. 2 by 6 is 1 by 3, which is 0.3333. It keeps on going. So 1 plus 0.3333 will be 1.3333. ठीक है? Option B. Option C मिल जाएगा. Nanu concept, right? Yes or no? 1.3, 1.3, you keep on going, right? Okay. Next question तो आ गया जल्दी. Okay, these are simple question. Highest ratio of specific heat gamma is possible for which one? Let me see who's the first person to give me the answer. The first person to give me the correct answer for this. कौन है वो? मैं हूँ डॉन. म्यारा C, then Mithilesh C बोल रहे, वीरेंद्र C, जिया असमत. हाइड्रोजन. Wrong. Helium. कैसे? अरे गामा is specific heat. It is given by the formula of 1 plus 2 by F. Gamma will be maximum. देख ले, degree of freedom is in the denominator, right? So gamma will be maximum when degree of freedom is minimum. Oxygen is diatomic, degree of freedom 5 usually. Hydrogen, degree of freedom 5. Helium, degree of freedom 3. Monoatomic, because helium has nannu chotu degree of freedom. So as helium has nannu chotu degree of freedom, it will be having the maximum gamma, क्योंकि gamma is inversely proportional to degree of freedom. देख ले, समझ में आ गया? Is the concept clear? That's what it matters. गलत हो गए. Okay, fine. अरे हाइड्रोजन is H2, so put F is equal to 5 here. 1 plus 2 by 5 हो जाएगा. Cool. Next, here we go. Next question आ गया. The ratio of CVs of 1 mole of a diatomic and a linear triatomic. देख ले, I told you, whenever we have triatomic linear, that will be specified clearly in the question. तो इधर तो specified है. जल्दी simple है. Which one? Option A. Option C, 7:5. A, C. At least if I have one single person to give me the correct answer. Very bad. अरे tell me, CV का formula क्या है? General. Okay, general formula is equal to F times R by 2, right? Question is to find the ratio of CV for diatomic, right, to CV of triatomic. ठीक है. So CV for diatomic is F times R by 2. What is F? F कितना? How much is F मेरा? चलो, अरे F is equal to, for a die it is 5. So this is 5 times R by 2 divided by. For tri, what is degree of freedom? That's 7. So 7 times R by 2. R by 2 cancels. 5 by 7. We have the option B as our correct answer. Got it? Yes or a no? Yes or a no? Yes or a no? Sir, please sometimes give any one of the option also, so that एक option कम हो जाएगा ना आप लोगों के लिए. Got it? Everyone went for the other उल्टा वाला option पे, पता नहीं क्यों. Okay, so I hope this concept is also clear. छोटू नन्नू मुन्नू और छोटा concepts है. We'll do that and we can wind up today's session. ठीक है? Ready? हाँ हो गया. My dear भैया रे बिल्कुल, my dear awesome बच्चा लोग, हो जाएगा. ठीक है? At the end of the session I'll be singing a song for every one of you. उसके बाद ही चलेगा. Okay. Now we will find out the molar heat capacity of a solid, any kind of solids, okay, and for water also. ठीक है? Same method, same concept we are going to apply. Now we are going to approximate in the case of solid also, right? The internal energy, though it is the sum of kinetic energy plus potential energy, we are only going to consider kinetic energy here. Okay? Potential energy here also we are going to approximate as 0 just by considering to the concepts of gases. Gases pe obviously it is 0 because one of the assumption is force 0. So here we are going to approximate that concept from gases here so that we can use it for finding molar heat capacities accordingly. Okay, छोटू नन्नू मुन्नू approximation कर रहा है, fine है ना? ठीक है, देख ले everybody listen. Now U is equal to kinetic energy, and kinetic energy is equal to F times half kBT. This is for one single molecule. For Avogadro number we already know, multiply it with Avogadro number Na. Avogadro number मतलब 1 mole के लिए if you have n number of moles kinetic energy होता है into n. Clear? Fine है ना? Okay. Now we just need to substitute the value of F, then it is done. Okay. Now we know that solids are very heavily packed. So can it have a translational degree of freedom? Can it move from one point to another point? Nahi, 0. Okay. Can it rotate? No, it is totally packed. So a rotational degree of freedom be 0 hota hai. So tell me which is the only energy mode it can have? Are only vibration. Yes or no? Yaad hai. Okay. Solids cannot move from one point to another point. So it can only vibrate from its own position. So dekh le, this solid molecule can vibrate in the x direction. We already know that for every vibration it adds 2 degrees of freedom. Q. Because every vibration means it is a combination of one kinetic energy mode plus one potential energy mode. Q. Array vibrate karne pe it is moving, it will add one kinetic energy mode. Okay, and when it is vibration, position to change ho raha hai, so it will add one potential energy mode also. So for every direction of vibration, it will add 2 degrees of freedom. ठीक है ना? So when it vibrate in x direction, 1 degree of freedom. When the particle is vibrating in y direction, 1 degree of freedom. When the particle is vibrating in the z direction, another 2 degree of freedom. ठीक है? So for an solid, total degree of freedom is 2 plus 2 plus 2, 6. So substitute kar le, 6 times half into kb into Na is R. Here we have N or T. Okay. 6 by 2 is 3 N R T. This is internal energy. Okay. So change in internal energy क्या होता है? What is change in internal energy? 3 times nr delta T. Why? Because we can change the internal energy once the temperature is changed. So change in internal energy will be equal to 3 nr into change in temperature. ठीक है? Fine. Okay. Internal energy का formula क्या है? NC delta T is equal to 3 times nr delta T. Cool. Fine. Okay, N cancel, delta T cancel. So molar heat capacity for any solid is equal to 3R. Clear? Clear. Okay, these are for solids. Note down भी कर ले. Everything is fair in love and war. No more arguments to prove that your answer is wrong, sir. अरे मेरा answer कब wrong हो गया? Or are you telling that there is no way my answer can go wrong? वही बोल रहा है. बोल क्या रहे हैं आप लोगों ने, समझ में नहीं आ रहा है. इज दिस क्लियर है ना? आई होप यू ऑल हैव नोट भी किया अच्छे से, ठीक है, विदाउट लीविंग एनीथिंग. ओके, ठीक है. नन्नू मुन्नू छोटा छोटा और कॉन्सेप्ट्स भी है, मतलब विद इन 10 मिनट्स कॉन्सेप्ट हो जाएगा. ओके, देख ले. Everyone listen. So we have done, right, the molar heat capacity of solids. Okay, so similarly we are going to find out for water. Okay, what are we going to do for water? Also we are going to find out yes, the molar heat capacity. It's very simple. We are actually going to compare the concepts of solids, what we already have done, right, and I'm going to take those concepts, apply it here in the case of water also, so that we can get the molar heat capacity here. ठीक है, water देख ले, H2O, right, which means 1 oxygen 2 hydrogens, ऐसे है ना. Okay, now how many of you do remember, देख ले, for every single atom of solid 2 + 2 + 2 6 degree of freedom was there. Yes or no? Yes or no? How many were there? For every single atom 6 degree of freedom was there for solids. Applying the same concept here, water has 3 different atoms, where each atom, if you apply the concept, there will be 6 degree of freedom with this atom will be having 6 degree of freedom, and this atom will be having 6 degree of freedom. मतलब total degree of freedom कितना होता है? 6 + 6 + 6 18. अरे बाप रे, वाटर का देख ले कितना डिग्री ऑफ फ्रीडम. इट्स सो फ्री है ना, इट कैन मूव इन एनी डायरेक्शन. यू विल बी लाइक, सर हमको भी इतना फ्रीडम मिल गया तो वी कैन गो टू एनीवेयर. ठीक है, सो डिग्री ऑफ फ्रीडम फॉर वाटर हमको मिल गया 18. सो लेट्स फाइंड आउट इंटरनल एनर्जी, which will be equal to kinetic energy, which will be equal to F into, right, half kBT for one single molecule, for 1 mole multiplied with Avogadro number, we already have discussed, for n moles multiplied with it. Okay, F degree of freedom is 18 into half, Na into kb is RTN. What is 18 by 2? That is 9 nRT, and that is internal energy. Okay, simple, right? Have a look at it. ठीक है, U is equal to 9 nRT, so delta U is equal to how much? 9 nR delta T, because when temperature changes, delta U changes, so delta U is equal to nR delta T. ठीक है, डेल्टा यू का फॉर्मूला क्या है? NC डेल्टा T इज इक्वल टू 9 टाइम्स NR डेल्टा T. कैंसिल कर ले डेल्टा T, N कैंसिल कर ले, C का वैल्यू मिल गया 9 टाइम्स R. सो वी गॉट इट. व्हाट, क्या मिल गया हम लोगों को? मिल क्या गया? Molar heat capacity for water, and that's 9R. We just have got it. If it is clear, give me smiling faces. Anera, Sumit, Rukshar, Shreya, Mithilesh, Jia, Spider-Man, No Way Home. Name is Spider-Man, no way home, and there is some car there. Which car is it? Ford car. Perfect. Preeti, Rukshar, Devika, Sapna, Sumit. Clear? Okay. Can I do one last concept? This is the last concept, Nannu Munnu concept of 3 minutes. Once it is done, we'll do some questions, we'll wind up this chapter. That's it, done. Ready everyone? Okay, ready? Last concept. देख ले, everybody write it and then we are done. Which is mean free path. क्या है? Mean free path. Very simple है, right? देख ले. If we consider gases, बहुत सारा molecules होता है, right? I am drawing all the molecules in big sizes. Okay, this is the molecule 1, molecule 2, molecule 3, molecule 4. बहुत सारे molecules हैं, right? बहुत सारा molecules हैं, right? And we know that the molecules are under constant random motion. देख ले, the molecule from here will be moving and it will collide with the particle 2. Right? Won't it be covering some distance? Let me mark it as lambda 1. Let's say after colliding with 2, the particle 1 has started moving towards 3 SA and it will collide with 3. Let's say the distance it has traveled is lambda 2. After colliding with 3, from here 1 again moves on and it collides with 4. Let's say the distance is lambda 3. Just like this, it will be making so many and n number of motion, right? So these lambda 1s, lambda 2s, lambda 3s and all these till lambda n's, right? Those distances a particle makes before two successive collisions means two adjacent collisions. That distance covered, here we have marked as lambda 1, lambda 2, lambda 3. Okay? Those distances we call it as free path. I guess how much what is free path? Free path is the distance between, or the distance a particle travels between successive collision. एक successive collision पे how much distance it travels, it is called as free path. I'll write it here. Free path क्या होता है? What is free path? It is distance traveled by a particle during successive collision. We call it as free path. Okay. Now we know that during different collision we'll be traveling different distances. Now if you find out the mean value of all those distances, lambda 1, lambda 2, lambda 3 plus lambda n, the whole divided by n, that is called as mean free path. Matlab the average distance traveled by a particle during successive collision is mean of free path. वो होता है mean of free path. And the time taken, which is not so much important, sometimes you listen to this word. Okay, the time taken between two successive collision, I'll write it as relaxation time, which is usually represented with the symbol of 2. The average time taken between two successive collision होता है relaxation time. Okay, cool. नन्नू मुन्नू मिल गया, isn't it? Nannu munnu concept. Okay. Now there is a simple formula also given here. If you are having a molecule of diameter d, right, the mean free path lambda dash is given by the formula of 1 by root of pi to pi है, ठीक है, d square, the diameter of the molecule, into n. This is not number of moles, okay, this is a number of molecules per unit volume. मतलब if I take 1 meter cube of volume, how many molecules of gases are present, वो होता है ये n, ठीक है. So don't confuse with what we already have. आ गया तो आ गया, समझ तो आ गया, बोल दे ना 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 ना. Yes? Okay. And let me say so proudly, we have completed the very last topic from this chapter of Kinetic Theory of Gases, and we are done. And that was the last concept. We'll do some 2-3 questions and we'll wind up the chapter. You ready? We don't have 10 PM session today. आज तो 10 बजे का सेशन नहीं है, कैंसिल किया है. Okay. एवरेज फाइंड आउट कर ले, लैम्डा 1, लैम्डा 2, लैम्डा 3, लैम्डा n, उसका एवरेज कर ले. जस्ट टेक द एवरेज ऑफ दैट. वो होता है एवरेज डिस्टेंस. ओके, एवरीवन इज लाइक सर सॉन्ग दे दे. ठीक. As you all know, I know only 6 to 7 songs, so I'll be listening to the same songs. Okay. Let me try the song. ठीक है? गिटार आउट ऑफ टोन है मेरा. चलो. Go for another song. Okay, we'll do this song. क्यों आजकल नींद कम ख्वाब ज्यादा है, लगता खुदा का कोई नेक इरादा है, गलता फकीरा दिल शहजादा है, लगता खुदा का कोई नेक इरादा है. क्या मुझे प्यार है या कैसा खुमार है, या क्या मुझे प्यार है या कैसा खुमार है, या ओ चादर है, जब से मिली हो तुमको बदला हर एक मंजर है. देखो जहाँ में नीले नीले आसमां तले रंग नए नए है जैसे खुलते हुए, सोया था ख्वाब मेरे जागे तेरे वास्ते, तेरे ख्यालों में भीगे तेरे वास्ते. क्या मुझे प्यार है या कैसा खुमार है, या क्या मुझे प्यार है या कैसा खुमार है, या ओ Okay. Yes sir, प्यार है. Okay. Thank you so much. Thank you Devika, Trisha, Mithilesh, Sapna. बहुत बुरा गाते हैं सर. Thank you so much Spider-Man. Super. Thank you Muskan, Zafar. Thank you Rukshar, Jia, Sumit. Fun with social studies. Anaira. We love you to the moon and back, Anaira. Arey, thank you. Safar, Sumit. Arey, thank you so much everyone. Means a lot. Fine. Okay, so I'm giving you some questions here. Okay, so it is simply based on our mean free path ka question hai. So this time I'm going to give it as homeworks. So हमारा पहला homework for the day, right? So everyone do it. The answer is going to be option C. सब करना है, मतलब it is a direct formula substitution for mean free path का. Everyone after the session, I want everyone of you to do. ठीक है? It shouldn't be like a class. You guys come here and भैया जी तो करेगा, अमीर सर ने करेगा, हम तो मजा ले लूँगा. ऐसा वाला नहीं. You guys have to do it, right? Okay. So this is one of the homework, and this is the second homework. ठीक है? And this is going to be the answer. ठीक है? करेगा everyone? Okay, so we have two questions here. The last two questions from the concept of mean free path. ठीक है? So we have completed the entire concept. I hope you all loved it. Enjoy किया सबने, I suppose. Cool. Press Trisha, Sumit, Mithilesh. Okay, yes. Okay. We never took it easy, sir. Always thought of you as a competitor more than an educator. ठीक है? I hope it's a compliment. But chalo, if you guys want to get some scholarship for your exam, for your college time also, here we are having an exam scholarship test which is being conducted by Unacademy Prodigy exam. Don't miss your chance, मेरा चलो. Next is going to happen on Feb 6 from 12 to 1 p.m. So jaldi se jaldi everyone can come and enroll now. And during enrolling, if you want to get the exam written for free, don't forget to use the code AMB10. ठीक है? Schedule is given, as you all can see. Date and times are given, and you all can see those amazing prices you're going to get. First rank MacBook Air, 2 and 3 Apple iPhone, 4 and 5 iPad. 6 to 40 Amazon Echo Dot, 41 to 100 Amazon vouchers. ठीक है? So class 11 का course, special classes I'll be soon updating you. Okay, so thank you so much everyone. Those who haven't liked the session, this is your time. Just move your cursor, click on the like button, and that's all you have to do for showing some love towards your bhaiya. ठीक है? Don't forget to subscribe so that you'll get all the notifications whenever a new class happens here. So bye everyone. Thank you so much. ठीक है? See you all in the next class. Till then.